By the end of this tutorial, you will be able to create complex interconnected systems in EDEM using parent-child functionality. Parent-child functionality works by assigning one object as the parent and another as the child. This allows the child geometry to inherit kinematics from the parent geometry, reducing the amount of kinematics required in complicated systems. The model used in this tutorial is a small 50 mm diameter coffee distributor, which uses a set of spinning needles to even out a rough surface of coffee grounds. First, set the correct units for the project. Create a bulk material and rename it to coffee. Enter the following material properties and add a material interaction. Next, add a dual sphere particle from the shape library and give it the following parameters. Create an equipment material. It is good practice to rename the imported equipment material. Now we will set up the physics of the simulation. Select the Hertz-Mindlin with JKR-V2 model. This contact model can simulate cohesive forces between particles without additional complexities, which is optimal in this simpler material model. Go to the model settings and add a cohesive interaction for the coffee material. Next, set the surface energy for this model. We can now import the geometry for the simulation. Set the units to millimeters, and keep the other settings as default. Rename each geometry to an appropriate name. Set the parent of each needle to be its corresponding gear. Then, set the parent of each gear to be the top geometry. Add a linear rotation kinematic to the top geometry and set the start time and initial velocity. Set the axis of rotation to the z-axis. Check display vector to check it's correct. Follow the same steps for each gear, but set the point of action to use center of mass. When modeling systems with complex movement, it's good practice to run a simulation without any particles to quickly check that the movement is correct. Open the Simulator tab, uncheck Auto Time Step and set the time step to 0.01 seconds. Set the runtime to 10 seconds and run the simulation. Move to the analyst, and play the simulation to check that the movement is correct. Now we've checked that the kinematics are correct, we can add particles into the simulation. Set the time step to 0, and add a cylinder geometry. Give the cylinder geometry the following transform and position. Right-click the cylinder and create a dynamic particle factory. Set the total number of particles and the generation rate for the simulation. Next, scroll down to Parameters, and select the settings for velocity, add a velocity in the z direction. We are now ready to simulate the model. Turn Auto Time Step on, set the time step, and simulation time. Run the simulation, and once the simulation is complete, go to the analyst. Next, we can color the particles by height to visualize how they change over time. Select Color by Position and set the component to the z-axis. Feel free to experiment with different colors. Set the minimum values and maximum values. We can now play the simulation again, seeing how the pile will smooth out over time.